Hello everyone, welcome to CodeSoft. In this video, we are going to talk about the problem missing number in an array. So let's get started. Now the problem statement says that you are given a list of n integers and these integers are in the range of 1 to n plus 1. So if there are 5 integers, then the range becomes 1 to 6, that is n plus 1. Now there are no duplicates in the list. One of the integer is missing in the list. So that is obvious because if the range is from 1 to n plus 1 and there are only n integers, then there is always an integer that is missing in the array. Now our question says that we need to find that missing element. Okay. So if I talk about an example test case, let's say we have an array that consists of 4 elements, that is 5, 4, 1 and 3. So n equals to 4, therefore range becomes 1 to 5. Now in the range of 1 to 5, you can see there are all the numbers except 2. So the 2 is missing and 2 is the required answer in our question, right? So I would request you to pause the video and try this question on yourself. If you're not able to, then please refer to this video. So let's go to the first solution. So the naive solution says that sort the array. Okay. Now after sorting the array, we will get the elements of the array in the order of increasing. So we can actually check that whether an element is present in it or not. So what we'll do is first sort the elements, then traverse from 1 to n. So we will go one by one and keep checking whether that particular value is present in or not. So the missing value, whenever it will encounter, we will actually be able to find it. So this solution will take O of n log n time. Why so? Because we are sorting the array and sorting takes at least n log n time if we do by merge sort. So if I show you the implementation of this problem, so we have taken the same array. N here refers to 4, that is the number of elements. We are sorting here with the help of STL library. You can apply any sorting algorithm of your own. Now we are taking an element that is count equals to 1. So this variable will actually be used to compare the sorted values and to check whether they are in order or not. Next, we have declared a variable answer that is having the value of -1 initially, because this answer will store the final value of our missing number. Okay, and after that we are looping from 0 to n, that is we are traversing the array. So when we have so let's say after this step our array will become 1, 3, 4 and 5. Okay, cool. So after this we'll start traversing this sorted array and we will check if count equals to arri. We will just increment count. That means that okay, we are going in the right track. We haven't found the missing element yet. How so? So in the initial condition, if you see the first element arr 0, that is arr 0, that will be 1 and count will also be equals to 1. So we have matched 1. Now we will just increment count plus plus, count becomes 2. Okay, and we will go to, again we will loop through the array. I will now be incremented to 1. So arr I becomes arr 1, that is 3, but count is only 2. So you can see that the value count is 2 and arr I is 3, that is 2 is missing. So we will go into the else part and we will save the value of count in answer. This is our answer that we actually want, and we can also break here because there is no need to loop through because we have found the missing element here. Okay, and we will just print our element and we have got the element 2 also, that is the required answer. A small check we have added, that if answer equals to -1. Now suppose in this scenario instead of 5 we had 2, right? So this array would have become 1, 2, 3 and 4. So in this case, our sorted array would have become 1, 2, 3, 4. So all the sequential values would have been present. So at the end of the loop, the answer would not have been updated and it would have been -1. So in this case, the missing element is 5, but it is not present in the array and also is not breaking in the sequential manner. So at the end of this, if answer equals to -1, that means that the last, that is n plus 1th value is missing in the array. And so we can set our answer as n plus 1. If we run this, you will be able to see that our missing element is 5 in this case, correct? So this is the naive solution. Better solution will actually is possible if we use the concept of XOR. So let me just brief you with XOR. So XOR is a bitwise operator. It returns 1 when both the bits are different and 0 when both the bits are same. Okay, so let's say there are two numbers, that is 2 and 3, and we are XORing them. So 2 in bit format becomes 1 and 0 and 3 in bit format becomes 1 and 1. So if we XOR both of them bit by bit, so if we look at the 0th bit, that is 0 and 1. So both of these bits are different. So our XOR will result in 1. And if we talk about the first bit, both of these bits are same. So our XOR will give us 0. So our answer become 1 in integer after XORing 2 and 3. Now you can see that if we XOR the same numbers, that is 2 and 2 or 3 and 3 or any same numbers, they will result in 0 because all the values, all the bits are same in both the numbers, and our XOR returns 0 whenever there are same bits. So this is the property of XOR that we will actually use to solve our missing number problem. So the optimized solution using XOR is XOR all the elements of the array, also XOR them with numbers from 1 to n plus 1, that is our range, and store it in a variable. So after doing this step, the variable will actually store the missing value that we want. How is this? So let's just look at an example and see. So in the same example where we were having 5, 4, 1 and 3, n equals to 4, range becomes 1 to n plus 1, that is 1 to 5. Let's XOR all the elements of the array first. So this becomes 5 XOR 4 XOR 1 XOR 3. Correct till here. Now the second step is we actually have to XOR the range of 1 to n plus 1 also, that is 1 to 5. So after here we are actually XORing 1, 2, 3, 4, 5, the entire range with the result from XORing all the elements of the array. We will store all these value in a variable, and this variable will actually have the missing value. How? You can see that here all the numbers are occurring twice. That is 1, you can see it is occurring twice. 2 is also occurring, 2 is occurring only once. 3 is occurring twice. 4 is occurring twice, and 5 is also occurring twice. So we can break it as 1 XOR 1 XOR 2 XOR 3 XOR 3 XOR 4 XOR 4 XOR 5 XOR 5. Now we know by the property of XOR that if we XOR two same numbers, it results in 0. So this becomes 0, 3 XOR 3 becomes 0, 4 XOR 4 becomes 0, 5 XOR 5 becomes 0, and we are only left with 2, that is occurring only once, and that is the missing number that we want. So this is the solution that we actually are framing with the XOR property. So let's just implement this. Let me just remove this part. Okay, and let me just change my value back to 5. So the first step is we need to declare a variable answer that will store the XOR of all the values. We will initialize it with 0 because initially it is having no value. We will first loop through the array, and we will XOR all the values of the array and put it in answer. So answer XOR, so we will just do answer XOR arri, and we will close our loop. Okay, after this what we have to do is we have to XOR from range 1 till n plus 1. So we start from here and we have to actually go till n plus 1, and inside this what we have to do, we just have to XOR the index I with it, that is all the range. So after this step we will actually get the missing number. So this is a very simple implementation. We just need to XOR all the elements and the range, and you can see the missing element is 2. That is what we actually want from this question. So this is another optimized solution that we actually use, and this is actually taking O of n time only, which is a very good solution. Now there is another optimized solution possible for this particular question. I will discuss it with you and you can try to implement it on your own. So we know by mathematical induction that sum of first n natural number is n into n plus 1 by 2. Right now, but if we have first n plus 1 numbers, so the sum becomes n plus 1 into n plus 2 divided by 2. Correct. So this is the sum that we actually have for first n plus 1 number. Okay, we can actually use this formula to calculate the sum. This becomes our first sum. Okay, the second sum becomes by when we actually sum all the elements of the array. Okay, so we now have two sums, one by adding all the elements of the array, and second by using the formula. Now in the formula you will see that all the numbers from 1 to n plus 1 are included, but in the second sum, that is by doing the sum of all the elements of the array, there is one missing element. So if we subtract both the sum, that is if we do first sum minus second sum, we will actually get the missing number. So this is also a very good solution, and the time complexity here again is O of n, because we are doing the sum of elements of the array, and that will take the time O of n. So that's all with this video. I hope the concepts are clear and this question was clear. Stay tuned to add more Festoons into your knowledge garland. And till then, please keep subscribing. Thank you.